There are 5 types of reactions. You want to take notes on this? I'm going to give you a very high overview of them, okay? You should be able to recognize them just by the format. There are 5 reaction types. 5. This is shorthand for reaction, okay? RXN. 5 reaction types, right? All right, I'm going to give you examples of each. All right, so here's what you got. You have synthesis, decomposition, single replacement, single sometimes you'll hear it called displacement, same thing. All right, double replacement, okay? I'm gonna write it the other way. Replacement and displacement are the same thing. So I'm just gonna write so you can see what each word could be, okay? So this one, displacement. These are the same thing though. Displacement or replacement, same thing. All right, so replacement or displacement. So you may see double replacement or single displacement. All right, and then the last one is combustion, okay? These are the 5 reaction types, okay? Typically in a normal school year, I would also make you learn how to write the products, okay? Or predict the products, I should say. But for now, I just want you to be able to recognize the reaction types, all right? All right, so here we go. Let's start with, anybody know what synthesize means? What does synthesize mean? Or can somebody tell me what decomp means?
Decomposition is breaking down.
Decomposition is breaking down. Excellent. All right. So here's how you recognize a decomposition reaction. Okay. You're going to have one reactant. I'm just going to say AB. Okay. One compound, and it is going to break down into 2 products. Okay. Possibly more. But that's how you're going to recognize it. You have one reactant, okay? So for decomposition, you have one reactant that breaks down, okay? That breaks down. It decomposes, which is why it's called a decomposition, okay? Okay. So AB is just, it could be like sodium chloride or whatever. It's something that's stuck together, one reactant. So if you don't know what a reactant is, that's the first thing. You have to know what a reactant is. And it breaks down into 2 products, okay? Synthesis is going to be the exact opposite, using my letters. Could you tell me what I would write for synthesis if it's the exact opposite? A plus B, Arrow. AB, excellent. All right, synthesis means you are synthesizing something. You are sticking 2 things together and you're gonna make one thing, okay? This, you have one product, okay? So one, you have one reactant, one, you have one product. These are ones, all right? You're gonna have 2 reactants that come together to form one product, okay? 2 reactants that come together to form one product, okay? Pretty easy so far. So for example, again, this one would be the opposite. If I said that this one was NaCl and it broke down into Na plus Cl2, okay? That's not balanced. Then this one would be Na plus Cl2 makes NaCl. Again, these aren't balanced, but this would be, that's what they would look like, okay? All right, single replacement. Single replacement, okay? You're going to have a couple and someone who is single. A couple and someone who is single, okay? If we're thinking about it in terms of relationships. So maybe you have AB, that's your couple, all right? Plus C, okay? And what they're gonna do is they are going to switch off dates, okay? If AB is the it couple in school. They've been going out for however long, okay? C is gonna break them up, and C is gonna start dating one of them, and the other one's gonna be single, okay? So in this case, we would have something like AC is now the new couple, and now B is by their long self, okay? That's a single replacement or a single displacement, okay? We're not going to get deep into that, but sometimes C is not cute enough for A and B to break up, and sometimes nothing happens, okay? All right, double displacement. What do you think that's going to look like? What do you think double displacement is going to look like? Think about.
Would that be like one side of the equation is completely switched up on the other side of the arrow?
I think what you're saying is exactly right. Could you tell me, what about using letters? What would you write?
Like AL plus.
Could you do it
CL.
using these? Could you do it with these AB, like what we've been writing?
Oh, okay. You mean like A2?
Like what we've been doing here, like we've had A, B, C, A, B.
AB plus C, and then it would be like AC plus or hang on, I'm trying to think.
No, you're right. You're right. I'll go ahead and help you out. And Josh was saying the same thing. So
wait, would it be like AD plus BC?
Excellent. AD plus BC. Excellent. Here you have two couples, okay, and they just switch dates. Now, the only thing with this one, I want you to be extra careful with, which I probably won't get into it, but when they switch dates, whoever's in the front needs to stay in the front. So like A needs to stay in the front and C should have been in the front. So let me just switch this, but I'm not as concerned with that, okay? So let me do CB, okay? Not as concerned with that, but okay. But it is two couples and they switch dates, okay? Two couples and they switch dates, okay? So that's why the other day, people were saying, oh, I get it. We did one of those equations and it was like lead nitrate plus sodium chloride, okay? Lead nitrate plus sodium chloride. And on the other side, you ended up with lead chloride and sodium nitrate. They just switched dates, okay? All right, the last one is combustion, okay? Combustion is the hardest to balance, but it's the easiest to recognize. This is what combustion always looks like, okay? Combustion will always be literally like, and these are elements this time, not letters, okay? Carbon with some number down here and hydrogen with some number. Whew, thought I had to sneeze. Plus O2. And on the other side, you will always have CO2, so carbon dioxide, and H2O, which is water. Okay. Pardon me. And that's every single time. So combustion reactions, the only thing that's really going to change, are these numbers right here. So you may have something like CH4, or you may have C3H8, or I may have C4H10, but everything else is going to look the same. It's going to be O2 plus CO2 plus H2O, okay? All right.
I have a question about combustion.
Okay.
So when there won't be any other elements like in the equation as well, like.
Correct.
Okay.
Anytime I give you a combustion reaction, it will always be, the only thing that will change is this box right here. And that's like with these pink ones. So it would be like CH4 plus O2 yields CO2 plus H2O, or C3H8 plus O2 yields CO2 plus H2O, or C4H10 plus O2 yields CO2 plus H2O every single time. So combustion should be very, very easy to recognize, okay? All right, so for example, okay, I'm gonna put up a sheet and let's just see All right, if you did not write these down, please write these down or snap a picture super, super fast. Because I'm gonna put up a sheet and I want you to tell me what type of reaction it is, okay? I'm gonna put up a sheet and you tell me what type of reaction it is. And we'll get this in and then I'll just open the quiz, but we'll have Wednesday to work on it as well. So go ahead and write these down super fast if you didn't finish writing them down, okay?
Miss Payne,
Yes.
I think you were glitching when you were talking. What did you say about the quiz?
I'm gonna do some practice with just identifying reaction types. And then on Wednesday, I think on Wednesday, I'll just give you guys like one big quiz and we'll be done. One couple.
Okay.
And single. And this is two couples. All right. So let me pull up. Give me 1 second. All right, let's talk about. All right. I'm trying to find one that's not word equation. All right. So give me 1 second. Hopefully everybody got that down. And I'll do a new share. All right, so for example, let's look at all right, let's look at number 1. All right, number 1. All right, so this is how you should be able to figure out something. Number 1, does this look like, let me see if I can switch between this. Oh no, it went away. All right, you're gonna have to do it based off your picture. Number 1, does this look like something breaking down or two things making one thing? Two couples, a couple and a single, or combustion? What do you think? I can tell you what's on the other side if that helps. On the other side, you essentially have, oops.
Two couples.
It is two couples. On this side, you have NaNO3 plus PbCl2. So these are two couples and they switch states. This is a double displacement, okay? When I say two couples, what I'm referring to is here's one part of the date, here's, okay, that's one part, and then here is the other part. So this is two couples, okay? Two couples. All right, I can tell you on the next one, you're gonna make HCl. So what do you think? Single, double, synthesis, decomp, or combustion?
Decompression.
Single.
I heard two things. Say again. So you got two things and you're gonna make this.
Synthesis.
Yes, synthesis, very nice. This is synthesis. Two things and you're making one product, okay? All right, on this one, you're gonna have ZnNO3, 2 plus AgCl. See, typically you guys will be telling me what this was.
Double displacement.
Very nice, double on this one, okay?
That's decomposition.
Decomposition, excellent, all right. Then what about this last one down here at the bottom?
Combustion.
Combustion, excellent, okay. Fantastic. Let's see if we can do it with some word problems. I wouldn't give you word problems, but that's all I got left. So let me do that. Any questions on this? Sorry, before I erase it. Everybody understand how the people who were answering these got these? Okay. Super fast. All right. Two couples and they switched dates. Okay, so the Na now is dating the nitrate. The lead is now dating the chlorine. On this one, I made one product. On this one, I made one product. So it was synthesis. All right. On this one, again, the couple switched date. Zinc started going out with nitrate. Silver started going out with chlorine. All right. On this one, we had one reactant. All right, and it broke down. So that was decomposition. And this one, you had your C2H6O2 CO2 H2O. Okay. All right, let me show you one more and then we'll be done for the day. All right. Where's the other one I was gonna do? All right, I'll try to write it so you can see it. So here's the same thing. All right. So potassium chloride, I'm looking at number 1. All right. Potassium chloride. So this is, all right, KCl plus AgNO3 yields KNO3 plus AgCl.
Double.
Excellent. Everybody see that that's double. Questions? Good. Okay. All right. I want everybody to give everybody time to think about this one for a second. So let everybody think for a second, then let's see if we can get it right. All right, whenever you're ready. Anybody got it? For number 2, this was double.
Would that also be it? No, wait, never mind. That's gonna be a single.
Very nice. Josh said it as well. This one is single. Iron's all by himself, then copper and sulfate are dating, and then they switched. Okay.
Will that be a single as well?
Not quite. Look carefully.
Combustion?
No, combustion always has something plus O2 yields CO2 plus H2O. How many products or reactants do you have?
On what you just wrote or the problem?
On this one right here. Let me write this again. Let me write this neater. Could be my handwriting. On this one, you have NaClO3, produces sodium chloride and oxygen. What'd you say? Here are your answer choices up here. You got synthesis, decomp, combustion, single, or double. Yes, very nice. Anybody online? They got it in here.
Decomposition.
Very nice. This one's decomposition because it is breaking down. You got one thing and it's breaking down. One thing and it's breaking down. All right. Let's see if let's do number 5 and then we'll be done. All right. Beryllium fluoride, BeF2 plus Mg yields MgF All right. I'll go ahead and write this one too. Na. All right, number 5, I got an answer for number 5 in here. What do you guys think?
For number 5,
Mm-hmm.
it looks like combustion maybe.
Okay, tell me why combustion.
Oh no, it's separated. My bad. If it was the other way around.
Is it synthesis?
Not quite. Synthesis, you would have one product.
Oh, okay.
Synthesis will be one product. Somebody in the chat, let's see who it is. Charles says single, and in here, Elmer also says single, and he is correct. So listen, on the single ones, look, single element and a couple. Here's another couple, single element. And then over here, I have a single element and a couple, single element. So those are your single ones, okay? All right, what about number 4? And then we're gonna be done. I'll tell you what I want you to do after that. Number 4, look, I have one thing on the left side of the arrow. And what's it doing on the other side? It is breaking down or decomposing. That one's decomposition, okay? One thing on the left side, decomposition. One thing on the right side, synthesis, okay? Combustion literally will look, let me show you this and then we'll be done. Combustion literally looks the exact same every single time. Let me show you a set of combustion problems, okay? This is a set of combustion problems. Here's an example of a combustion problem. Here is the key to my combustion problems. They literally all look the exact same. Oh, I can't see the, there we go. Combustion always. The only thing that's changing is this front one. Is CH something, C some number, H something, O2, CO2, H2O, O2, CO2, H2O. Every single time, this is what combustion looks like, okay? Every single time, all right? If I'm looking at a decomposition key, okay, every single time, there's only one thing on the left side. There's only one reactant, okay? Find that one. There's only one thing on the left side of the arrow, okay? On synthesis, there's only one thing on the right side of the arrow, okay? Double, let's see, single replacement. Single replacement, you have one element and then one compound. One element and a compound and a single element and a compound and a single element, okay? And then double is actually the ones I like. So it's just, the couples just switch, see? So it's just switching, all right? All right, so that is it for today. I have taught, I believe, everything that I'm going to teach. Let me stop the recording.